Let ABC denote the outcome of three independent rules of a fair tetrahedral die. Tetrahedral die means you have four faces, and fair tetrahedral die means that chance of getting each face is same, and the different faces are marked with 1, 2, 3, and 4. The question is that if this quadratic equation ax square plus bx plus c equals to 0 has all real roots, the probability of this thing is m by n, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The greatest common divisor or the HCF of m and n, this is 1. So then we have to find the value of m plus n. So basically the problem is that we have to find the probability that this quadratic equation will have all real roots. If that probability is m by n, then we need to find m plus n. Also, in this quadratic equation, the unknowns a, b, and c, these are obtained by throwing this tetrahedral dice, and on that dice, the different possible outcomes are 1, 2, 3, and 4. So let us say A is the set which contains these four elements 1, 2, 3, 4. So here if I talk about sample space or the number of different quadratic equations that you can create. So for A we have four options, and same thing for B and C, right? In this quadratic equation ax square plus bx plus c equals to 0. For coefficient of x square, that is A, we have four options. Either you can get 1 or 2 or 3 or 4. And same thing for B and C. So using multiplication rule, the number of quadratic equations will be 4 into 4 into 4, which is 4 raised to 3. So these many quadratic equations are possible. Now we have to find the favorable cases. Favorable case means we have to find that how many quadratic equations will be there, which will have all real roots, right? Both the roots must be real. So we know that condition for real root is that discriminant must be non-negative, right? It should be either positive or 0. Then we can get real roots for a quadratic equation. So here the condition will be for favorable cases b square minus 4ac, this must be greater than or equal to 0. And now we have to see that in how many different ways we can select a, b, c, so that this becomes non-negative. Now from here it is difficult to see the different cases, so we can rewrite this equation as we can take AC on other side, and that means we can say that A into C, this must be less than or equal to B square by 4, right? 4AC will be, B square should be greater than 4AC, so that means B square by 4, that should be more than AC or AC less than this number. And now we'll take different values of B and we'll see in how many different ways we can select A and C so that we can satisfy this condition. And remember, ABC can be any number from 1 to 4. So first we'll take different values of B and then we'll see what are the different cases for AC, and from there we can get the number of favorable cases. So on one side we'll write different possibilities for B, and on other side we'll write the ordered pairs AC. So because it is tetrahedral dice and the different faces are marked 1, 2, 3, 4. So for B we have these four options. Either B will be 1 or 2 or 3 or 4. Right? These are the four possible values for B. Now remember, if B is 1, AC should be less than 1 by 4, and A and C also we have to select from here only. So the minimum product that you can create for AC will be 1 when A and C both of them are 1. So in this case will not get anything. Right? If B is 1, then you cannot make a quadratic equation with real roots because discriminant will be negative. If I take B as 2, then the condition will be, from here you can see that if B is 2, AC must be less than or equal to 1. So that means there is only one possibility that A is 1 and C is 1. Right? Only when both of these A and C, these two are 1 and 1, then AC will be less than, AC will be equal to 1, and we can satisfy this condition. Similarly, if I take B as 3, then the condition that we need to satisfy is that AC should be less than or equal to 9 by 4. 9 by 4 means 2.25. So A into C, that should be less than or equal to 2 point something. So one possibility is we can take A and C as 1, 1. Another possibility, A is 1 and C is 2. Next possibility, we can have 2, 1. Right, so these are the three possibility. We cannot make 1, 3 because in that case, AC will become more than 2.25. And finally, the last case, if B is 4, AC should be, if B is 4, then if I substitute that value here, so A into C, this should be less than equal to 4. And now we have to see that in how many different ways we can select A and C so that this will be either less than or equal to 4. So if I take A as 1, then you can have starting with 1, 1, we can have 1, 1, 1, 2, 1, 3, and then 1, 4. These four cases you can get if A is 1. Similarly, if I take A as 2, then we have 2, 1, 2, 2. We cannot make 2, 3 because in that case we cannot satisfy this condition. If I take A as 3, then we have 3, 1. We cannot take 3, 2. And finally, we can have 4, 1. So these are the different cases if B is 4. Right? These are the different possibilities for AC. Now, here we are getting one case. Then in this one, we are getting 3. And finally, in this last one, we are getting 4 plus another 4. So that will be 8, right? So that means here total number of cases, I mean, if you count all these different cases, you are getting 12 different cases. So those are the favorable cases, right? Now we have to find the probability that this will have uh, all real roots. So probability is nothing but number of favorable cases by total number of cases. So here we are getting 12 favorable cases. There are 12 quadratic equations for which discriminant will be non-negative and therefore they will have all real roots. And total number of cases, this is 4 raised to 3. You can cancel one 4 from here. So this becomes 3 by 16, right? This will be the probability. This is not the final answer. This will be the probability. Let us say E is the event that we have all real roots. So this is probability of E. And clearly you can see that there is no common factor between these two numbers. So now we can write the answer. The probability is m by n. So that means m must be 3, n must be 16. So m plus n, this will be 3 plus 16, which is 19. So that should be the correct answer for this problem. Right, so this was a problem where we have to, I mean, first use this condition that because it has all real root, discriminant must be non-negative. So it will be either positive or 0. And then write the given condition in this form that A into C, this is less than equal to B square by 4. And from there you can see that for different values of B, what are the different possibilities for AC. So we got 10 favorable cases, sorry, 12 favorable cases, total number of quadratic equation 4 raised to 3. So therefore probability 3 by 16 and hence m plus n, that will be 19, and that is the correct answer for this problem.